Okay, I'm going to wire the DC power to the controller because I haven't turned it on and I should check that it actually works. And then what I'm going to do is start thinking about how to assemble the proximity sensors. These are normally open NPN sensors which I bought from eBay. I was recommended these types by Harry, who makes the controller board I'm using for this project. I want to use two on either side of the X and Y axis of my CNC machine so I can scan the margin and determine the available cutting distance between them. I know some controllers have pins for their minimum and maximum limits, but the controller board I'm using only has single inputs for all the different axes. So I'm hoping there is a way of wiring the sensors in parallel to each individual input. Anyway, that's a problem for another video. These types of sensors seem to be the go-to ones for 3D printer owners who have decided to add a bed leveling feature to their machines. So there is a lot of information online about wiring them. But before doing this, I will power the controller board for the first time. I'm going to wire this a little bit longer than I obviously need, and then I'll cut it down. After I've done this, I will wire the proximity sensors to a 12V LED switch. I want to progress in stages, so I will temporarily wire up a single sensor using crocodile clips, which when activated will power the LED. Then I will wire two sensors in series, meaning one sensor must be activated before the second, and finally in parallel, so either switch can be activated independently of the other. Now let's see if this lovely control board turns on. Check 24 volts. Those are set to 24 volts. Now powering up the driver. Wow. It's receiving power. That is a really fucking bright LED. Jesus Christ. Okay, so I've just wired up the proximity sensor. It's an NPN. Normally open, and I've done it based on this diagram to start with. So I'm using a 12V bulb in this switch, which should light up when something is detected in front of the proximity sensor. Just sort of take these down a bit just so they're not. I think maybe I should have used a terminal block. So the blue wire is going to the negative, the black wire goes to the bulb, the brown wire goes to the bulb and then to the positive. So I'm just going to turn this on now. Need something metal. Wow, that worked. Can't believe it. That worked first time. Now I'm going to try wire up two sensors in series. Okay, so I've wired, I mean this looks like a complete mess, but I've wired this diagram here up now. Only difference I've done, as far as I could tell from this diagram, is instead of daisy chaining the power, 12V power from the load, I've gone straight from the power supply unit. Should really double check everything. So live comes out and goes to the brown on sensor 1 and to the brown on sensor 2, so imagining that's minimum and maximum. Then the live 12 volts goes into the bulb that I'm going to use as the load, and then goes to the black on sensor 1, which is there. Then I connect blue, which is the ground, to black, which is the signal on sensor 2, and then the ground goes to negative. Okay, here goes. Two metal objects in front of both. Okay, I think I've widened it. There. Why did I do it? Okay, this is wired in parallel. I don't think I've made any mistakes, but there's only one way to find out. Okay, that's good. That's what I want. And then they're both pressed. Okay, so what I need to do now is connect these to my driver board, and the signal has to be 5 volts or less. Otherwise I could fry this very nice piece of electronics here. I began thinking about different methods to do this, including using relays or even wiring the signal through a voltage regulator. But in the end, both Nathan from Opentronics and Harry, who makes the Phoenix CNC controller, suggested using a voltage divider. As I said earlier, the particular sensor I'm using are popular amongst 3D printer owners, and there were many sources online to suggest how to do this. I borrowed a 10 and 15 kilo ohm resistor from Nathan and wired this into the circuit, pulling the voltage down from 12 to just under 4. So ignore the color coordination, but this wire should be the signal and this one should be the ground. You can see. No. Okay, so I put something in front of the proximity sensor. When I put a piece of metal in front of the proximity sensor, you can see this goes to 0, which is the active low. One additional thing I noticed was for the sensor LED to work, I had to wire the ground back to the PSU and not the controller. I wanted to plug the controller into my laptop and simulate a homing sequence, but as I had not wired any other components, this didn't seem to work. Anyway, in the next video I'm going to assemble a pretty interesting looking enclosure and begin the process of laying out the components. Thanks again for watching.